China's towering mountains and steep river valleys present one of the most difficult challenges for water navigation in the world. Yet, on the Yangtze River and beyond, Chinese engineers have redefined what's possible. Take the Three Gorges Dam, where ships weighing up to 3,000 tons are lifted over 370 feet in just 40 minutes, using a shiplift system that relies on gravity and water displacement instead of brute force. Or the Goupitan Shiplift, which breaks records with its 199-meter height, moving vessels through 3 stages with astonishing precision and speed. These engineering marvels combine ancient principles like Archimedes buoyancy with cutting-edge technology, from hydraulic lifts to steel counterweights. They've turned once impossible routes into efficient trade corridors, saving hours of travel time while showcasing the ingenuity of modern design. How can a single system lift thousands of tons with such accuracy? And what makes these shiplifts safer, faster, and more sustainable than traditional locks? Stay tuned. You'll be amazed at how everything fits together. Did you know that rivers are like nature's highways, connecting towns, cities, and even countries? But they aren't always smooth sailing. Some rivers have sharp drops, rocky sections, or even waterfalls. So how do ships navigate these tricky spots? That's where dams, locks, and shiplifts come in. These incredible engineering wonders make it possible for massive ships to travel across rivers that would otherwise be impassable. First, let's talk about dams. At their core, dams are like giant walls that hold back water, creating reservoirs. These reservoirs serve many purposes, providing drinking water, generating electricity through hydropower, and controlling floods. But here's the catch. When you build a dam, you raise the water level behind it, creating a difference in height between the upstream and downstream sides. Ships need a way to cross this water step. That's where locks come into play. Locks are like elevators for boats. Imagine a big chamber with gates on both ends. When a ship needs to go upstream, it enters the lock, and the lower gate closes behind it. Then, water flows in from the upper section, raising the ship to the higher water level. To go downstream, it's the reverse. Water drains out of the lock, lowering the ship. It's simple, but genius. For centuries, locks have been helping ships climb rivers and canals, making trade and travel easier. The Mississippi River, for example, has a whole series of locks and dams that allow massive barges to carry goods like grain and coal far inland. But what happens when the height difference becomes too big for locks to handle? That's when we turn to shiplifts. Shiplifts are next-level innovation. They take the concept of locks and supercharge it. Think of a shiplift as a massive platform that lifts or lowers entire ships, much like an elevator in a skyscraper. These structures are essential for navigating around tall dams or steep river sections where traditional locks would be impractical. The idea of shiplifts isn't new. Early versions date back to the 19th century, but they've come a long way. Modern shiplifts, like the one at the Three Gorges Dam in China, are feats of engineering brilliance. The Three Gorges Shiplift, for instance, can carry ships weighing up to 3,000 tons and lift them over 370 feet in just 40 minutes. That's like taking an entire ship and moving it up the height of a 30-story building in less than an hour. These lifts use a counterweight system, hydraulic pumps, and state-of-the-art mechanics to make it all happen. Why are these systems so important? It's simple. They keep trade moving. Rivers and canals are some of the most efficient ways to transport heavy goods. Without dams, locks, and shiplifts, many of the products we use daily might take longer and cost more to reach us. Shiplifts, in particular, are game changers for regions with steep landscapes or giant dams. They save time, energy, and money while opening up new possibilities for river navigation. But how do these shiplifts work? What makes them strong enough to lift thousands of tons of steel and cargo? Let's break it down in simple terms. Think of a shiplift as a giant elevator, but instead of lifting people, it lifts boats. Huge boats filled with cargo or passengers. The way it does this is surprisingly clever, and it all starts with balance. A shiplift works on a principle you might have heard of: Archimedes principle. It's the idea that an object in water, like a ship, displaces an amount of water equal to its weight. This principle is key because it helps engineers figure out how to balance the massive weight of a ship in a chamber of water. Here's how it happens. Imagine a big steel tank, like a bathtub, filled with water. When a ship enters this tank, the water adjusts to hold the ship, and the entire thing, the water, the tank, and the ship, is lifted or lowered using a system of cables and counterweights. Let's take the Three Gorges Dam shiplift as an example. It's one of the largest and most advanced shiplifts in the world. The lift at the Three Gorges Dam is designed to handle ships weighing up to 3,000 tons. That's about the same as 200 school buses stacked together. The shiplift uses a chamber that's over 120 meters long, which is big enough to fit a ship and the water it floats in. This chamber is like a huge cradle that gently lifts or lowers the ship. Now, you might wonder, how does this system actually lift something so heavy? The secret lies in balance. On either side of the chamber, there are massive steel cables attached to counterweights. These counterweights are made of dense materials like concrete or steel. Together, the counterweights and cables make the system balanced, like a giant seesaw. When the chamber needs to go up, the counterweights go down. And when the chamber goes down, the counterweights go up. This balance reduces the amount of energy needed to move the ship. But it's not just about cables and counterweights. Motors and gears also play a big role. At Three Gorges, powerful motors work with the cables to control the speed and movement of the chamber. These motors are incredibly precise, ensuring that the ship stays level and stable during its journey. Even though the ship and chamber weigh thousands of tons, the system is so well engineered that it can lift the load smoothly in just 40 minutes. Without this technology, moving a ship through the dam would take several hours. Let's talk about the structure itself. The towers that hold the cables and motors are built to be incredibly strong. At Three Gorges, these towers are over 170 meters tall, taller than most skyscrapers. But building something this tall comes with challenges. For example, the sun heats one side of the towers more than the other, causing tiny expansions in the metal. This might not sound like a big deal, but even small changes can affect the lift's operation. Engineers had to design the system to adjust for these changes, ensuring everything stays perfectly aligned. Another great example of a shiplift is the Goupitan Shiplift on the Wu River. This one is even taller than the Three Gorges lift, with a total height of 199 meters. Instead of using a single lift, Goupitan has 3 separate stages. Why? Because splitting the height into stages makes the process faster and reduces the chance of delays. While one ship is moving through the first stage, another can already start its journey on the second. It's like having multiple elevators in a tall building. Each stage at Goupitan uses hydraulic lifts, which are incredibly powerful. Hydraulic systems work by pushing oil through cylinders to create force. These systems are so strong that they can lift a 500-ton ship at a speed of 8 meters per minute. That means a ship can pass through the entire lift in just about 10 minutes. Amazing, isn't it? Now let's dive into some safety features. Lifting ships is no small task, and safety is a top priority. For instance, if something goes wrong, like a cable snapping or a motor failing, the system has built-in brakes to stop the chamber immediately. At Three Gorges, these brakes are so effective that they can hold the chamber in place even if the motors lose power. The engineers also designed the system to handle extreme weather, like strong winds or heavy rain, ensuring the lift operates smoothly no matter the conditions. And maintenance? That's a huge part of keeping these systems running. The shiplifts at Three Gorges and Goupitan are inspected regularly to make sure every cable, motor, and counterweight is in perfect condition. Maintenance crews also replace parts before they wear out, ensuring there's never a risk of failure during operation. The Three Gorges Shiplift, for example, operates for 22 hours a day, with a few weeks set aside each year for detailed maintenance. Another example worth mentioning is the Shiplift on the Min River. This lift was designed for smaller ships with a capacity of 500 tons, but it's just as impressive. Like the others, it uses a combination of cables, counterweights, and motors to move ships. What makes Shuko unique is its compact design, which fits perfectly into the surrounding landscape. This shows how engineers can adapt shiplift technology to different locations and needs. In the end, shiplifts are more than just machines. They're a combination of ancient principles, like Archimedes buoyancy, and modern technology, like hydraulics and advanced motors. These systems make river travel faster, safer, and more sustainable, proving that engineering can solve even the toughest challenges. If you found this fascinating, don't forget to like this video, subscribe to the channel, and hit the notification bell. Have questions about shiplifts or other engineering marvels? Drop them in the comments. I'd love to hear what you think.